All right, everybody. So now that we've learned how to carry out a two proportion z-test in our notes and formulas, let's take a look at an example and see how straightforward this seems. In a medical study, 300 volunteers with a certain medical condition were randomly placed into two groups. The 200 of the patients were given a new drug for the condition, and 130 of them, that must be a typo, and 100 of them responded, and 130 of them responded positively. The other 100 patients were given a placebo, and 50 responded positively. Is there evidence at the 0.01 significance level that the new drug is more effective than the placebo? All right, so here we go. I'm going to define two parameters. I'm going to say let P subscript new equal the percentage of patients on new drug that improve. And then I'm going to say let P subscript placebo equal the percentage of patients on the placebo that improve. Hopefully that's pretty straightforward. Now, my null hypothesis will be that the percentage of people on the new drug minus the percentage of people on the placebo will be 0. This is basically my way of saying that an equal percentage of patients on both treatments experienced improvement. Both treatments are basically equally effective. The alternative hypothesis, we're looking for evidence that the new drug is more effective. So this time I want to say P subscript new minus P subscript placebo is greater than 0. If the new drug is more effective, then if we subtracted the percentage of new minus the percentage of placebo, we would expect the answer to be greater than 0 if the new drug was more effective. Okay, now I'm going to check the conditions. I'm going to say not that the 300 volunteers were randomly chosen. I may say that in another example, but here I want to say that the 300 volunteers were randomly, not randomly chosen, but randomly placed into the treatments. That's what we want to say. Okay, next, can I say that 300 volunteers is probably less than 10% of people with this condition? So notice it doesn't feel like I'm checking the conditions for both groups on these first two sentences, but I am. I'm just saying that it's the 300 people that were split into two groups is less than 10% of people who have this condition. Okay, now, here, I now have to check to see if all of those counts are greater than or equal to 10. So what am I going to say? Well, 130 of the 200 patients were experiencing improvement. So I'm going to say 130 people improved on the new drug, and that would be 70 didn't. And likewise, it is said that 50 people on the placebo improved and 50 didn't. all of those numbers are greater than or equal to 10. So I have to show that 4 numbers are all greater than or equal to 10. Okay, so now I can say the conditions for a 2 proportion z-test are met. Okay, so now I'm ready to move on to the math, and I've developed the 2 formulas for you, but there's a little bit more to it. You want to do this. P hat new drug is 130 over 200, which if I grab my calculator, what is 130 divided by 200? It is 0.65. 65% of the people on the new drug experienced improvement. P hat placebo is 50 over 100. So we know that that's 50%. Okay. All right. Now, what you want to do is you want to subtract P hat new minus P hat placebo. You want to subtract it in the same order that you stated your hypotheses. So that's 0.65 minus 0.5 is 0.15. That is the difference between the two. So there's a 15% difference. Now, the mean of P hat new minus P hat placebo is 0, our new formula. The mean is always 0. Okay, now for the fun ones. We have to calculate P hat pooled. And that is done by taking the number of successes plus the number of successes divided by sample plus sample. So that's 180 out of 300. In other words, regardless of which treatment you were in, 180 of the 300 people experienced some sort of improvement, and I'm getting 0.6. So now, what you need to do is calculate the standard deviation of P hat pooled. Well, that's going to equal the square root of, you put the 0.6 times 1 minus the 0.6 divided by the new drug sample size, plus you put the P hat pooled yet again times 1 minus the P hat pooled yet again divided by the placebo sample size. So take a second as I'm going to go silent and calculate this. Okay, I'm getting that the standard deviation of P hat pooled is 0.06. Okay, let me scratch this second example and get it out of my way. All right, now what we want to do is we want to draw a picture with our mean in the middle, which is 0. And we want our observed difference, 0.15, to be over here to the right. And here's our shaded area. We were expecting the difference to be 0, but the difference was 15%. So we're looking for our p-value. And the way we calculate our p-value, guys, we're back to doing a z-test. So we can use normal CDF, and that would be 0.15 for our lower bound, infinity, something big for our upper bound, 0 for our mean, and 0.06 for our standard deviation. So let's go silent again and pull up the normal CDF on the calculator, and let's type in what we have. Okay, normal CDF just came up with 0.006. Well, I think we can all agree that that's a very small p-value. So I'm ready to draw my conclusion. Since the p-value is less than the significance level of 0.01, I reject the null hypothesis. We draw that conclusion the same way we have been. Now, if I reject the null hypothesis, that means I'm in favor of the alternative. And the alternative is saying is that the new drug is better than the placebo. It's more effective. So that's what I'll say. There is evidence the new drug is more effective than the placebo. So I guess we better get that new drug out there.